Does anyone not have flaky tests today? No, nobody? No? I usually ask people when I'm at events, like who has flaky tests, or I always make the comment, everybody has flaky tests, and there's always one person that says, we don't have tests. That's how they get around that. All right, so as Julianne mentioned, I'm Brian Demers.
And I'm François Martin.
And together we figured out we have about 30 years of experience of rerunning tests. Okay, so we like to start off with some sort of big bang, right? So it's estimated that 36 billion with a B, dollars is wasted every year on developers, basically lost productivity based on rerunning flaky tests, right? And there's another sizable number here. We could end world hunger with about 40 billion, right? So we spend about as much money rerunning tests as we do, or as it would cost to end world hunger. So maybe we should fix this problem. Both of them.
Right, then I'm quickly going to run through the topics. So first we are going to look at what is a flaky test, and then we are going to look at how you can find them, and how do you deal with them, and finally, how do you fix them. And also you can see, by the way, there's a QR code here. You can just enter your email address and your name, and then you'll get an email from me with the with the slides, and you also get a recording. And also you get an ebook that I've written on how to fix flaky tests for free. So it's a nice bonus. So, you can always look at it and send it to colleagues so they can also fix the flaky tests together with you. All right, so the question is, what is a flaky test in the first place, right? And this is no flaky news, by the way. So the definition is it's a test that exhibits both a passing and a failing test result with the same code if you run it multiple times. And usually, if you do something multiple times and you expect a different result every time, this usually is defined as insanity. But in software engineering, we just call it flaky tests. Let's look at one of the first things that we have in flaky tests, which is having tests that are timing related, where they are flaky. For example, the case where you have, for example, a text box, and then you just enter a search term into it, and then you click on the button search. And then, sometimes you have tests where they say, oh, I'll wait for 1 second, and then I'm clicking on the first result. So, this wait for 1 second is making the test flaky, because, what do you do if the server is maybe just a bit slower this time, or maybe, your CI pipelines are just more congested? Then your test will be running slower, and then it might take longer than 1 second, so it might fail. Lots of people, if they have a case like this, they just extend it to 3 seconds and then 5 seconds and so on. And then it just gets worse. Sometimes you're at 30 seconds. And this doesn't solve the original problem because, if you're waiting 30 seconds every time, you're wasting a lot of time, just waiting for stuff to happen. And that's really way too slow. And so, yeah. Another one is test data related. So to give you some examples here, one of them is, let's say you have an input field where you have a prename and, it doesn't allow special characters. My name is really well suited for those kinds of things, by the way. Yeah, so this is something where you can have some issues where you may not test with this, special characters, and you might not notice that it's not working. And then, so you might have randomly generated prenames in tests, and they may contain the special characters, like in my name, just I mentioned earlier. And then, of course, this is a problem because maybe you have some tests that also rely on data in the database. But just in general, if you have data that suddenly has, for example, randomly generated data with special characters in it, where it's not allowed, then of course your test will fail because it cannot enter it in there, even though you didn't expect that. So yeah. If you have predefined test data in databases, you might have some dependencies between tests, actually. So let's say you have a test A that performs some actions, and then these actions are required for test B to run. And then this means you always need to execute test A before you can execute test B, which also wastes a lot of time, and might people might stumble across it because they might not know about this. So yeah, and also this means that if test A fails, midway, this means that test B will fail as well. So yeah, this is really a big deal. Because if you create a file in one test, for example, and you read that file in another, you might have also similar issues to that one. And then you also might have some failing tests due to just some inconsistencies. Like let's say you have some actions which change the test data on the database, but then later it fails on a later step. Then when you run the same test again, then if it fails in the beginning already, then the data is in a different state than it's expected, and this causes your other tests to fail, which is again not really nice. And then another example here is if you have, let's say, a unique constraint in the database that is violated from test data maybe already being created from a previous test that is not cleaned up. So you see there are lots of different cases like this. Then we have infrastructure-related ones. So usually that is due to unstable infrastructure. Like I mentioned, your CI pipelines might not always be as congested. Sometimes they're more congested, sometimes not as much. And then, your tests will run slower. And then you might introduce some issues there. So the test could maybe time out. This is like one of the effects that you could have from that. And these are kind of the ones that are the most difficult to reproduce usually. And here are some examples, like you might have some build runners that are under heavy load, as I mentioned, or maybe some microservices with networking issues. So for example, if you have a microservice which depends on another, and then you have heavy load, and then the other microservice doesn't respond as quickly, and then you might have a timeout which causes the test to fail. And then we have resource contention related ones, where it's about issues where you mostly encounter them when you run tests in parallel. So one example is, let's say you have multiple tests that are trying to, for example, write through the same file at the same time. Obviously, that doesn't work. And then you might have issues with files being locked, of course, right? And you might have some concurrent modification errors. And also, if you, for example, try to create a user with the same username that already exists, in the database, or that, like at the same time from two different tests, then of course you might also have clashes here, which results in issues. Exactly, because you will run into unique constraint violations, and with that you will have issues with the test failing, because the second one that tries to attempt to create the same user, cannot, obviously.
Right, so we know what they are.
Mm-hmm.
Why do we need to worry about flaky tests?
Great point, Brian. So actually, on the one hand, rerunning tests waste a lot of time, just like I mentioned a bit earlier. For example, I had at work one case where I had a test that was running for 1 hour, and that was really painful by itself. What was even more painful was that we introduced, or we updated a version of a dependency, and then suddenly our tests became really flaky. And the problem was we had to kind of rerun the tests about like 8 times until they passed. It was already somewhat flaky before, we were really trying to manage them but we had tons of them, so we didn't have time to fix all of them yet. But, it was manageable before, but now it has gotten terrible, right? You had to rerun them 8 times. And you can imagine with 1 hour per test run and then having to rerun them 8 times, you're basically babysitting the tests all day long to just simply get them to pass so you can merge your change. And then somebody merges in another change to master, and then you have to update your branch because we had that rule in our CI. And then you can run them, for 8 times again. Great fun, right? This is maybe, of course, a bit of an extreme case, but maybe it shows you like what could happen. And of course, every time you have a flaky test, if the build fails, you have to look at it and see, is it really a flaky test, or is it maybe an issue that is, a real issue that you need to deal with? Because of course you don't want to ignore them. And this could also result in your team starting to lose trust in your test results. It's really important, because if we have a test because we want to improve the quality of the software, and if we cannot trust the results, then the quality will also go down. And here I also had a case at work where, we had lots of flaky tests, and people just started to ignore the results of the build, and they just merged a pull request with a failing test because they thought, oh, the tests are just flaky, right? But it wasn't flaky. We actually accidentally shipped a bug to production, which was really bad. So yeah, this might result in bad software quality, as you have heard, from my example right now. And here is actually a funny story as well. So there's a story where pilots have been frequently ignoring an alarm in the cockpits of a Boeing 737. And this actually resulted in a fatal plane crash in 2005. Just like in a flaky test, the alarm was often not one that they had to look into, but sometimes they, there were like real cases, and this was one of them. And since they just ignored it, it resulted in a plane crash. I mean, again, usually we are not building software which has like life or death threatening situations in them. But yeah, kind of just to show you another example. And by the way, you can click on the link to learn more about this incident.
So let's talk a little bit about unit tests and integration tests, right? But to sell this point, who has a unit test that connects to a database or a REST API? Right, you're brave, right? The rest of you probably do, but you don't want to admit it, right? You're laughing because everybody's worked at a place where it's actually been the norm. Okay, so I'll raise my hand too, right? I'm guilty of this.
Same.
But it's not actually a unit test, right? That's some form of integration test, and that's fine. You call it what you want, but as long as you know that's not really what a unit test is. All right, everyone's seen this kind of pyramid before? Maybe not in an iceberg. But the idea is you have a lot of stable running unit tests at the bottom. Then as we go up, we have probably fewer longer running integration tests. And then at the very top, we have end-to-end tests. And there's different variations of this, but they're all kind of the same idea. So what I want to do is I want to invert this, the iceberg, right? We're going to put the unit tests at the top. Those are pretty stable. They're floating above the water, right? And then as we go down, we have our integration tests, right? That introduces a little more volatility, right? If we think about it, right? Again, you have database connections or REST APIs or some other external system you depend on. Your tests are only going to be as stable as those systems. And then at the very bottom there, we have those end-to-end tests, right? Now we're introducing potentially a browser. There's a bunch of browser configuration. You need to start the browser, right? But there could be some proxy issues on the machine. But we have network requests. I don't know, someone tweaked a CSS button and now your tests don't run right anymore. So the further you go down in the water here, the higher the potential of flakiness is, right? And we can think about it this way too. Right, as the complexity increases, so does the potential volatility. Right, so I know folks at a shop that I worked where we spent a lot of time writing integration tests, and it was good. You could get a lot of coverage from a few lines of integration tests, so that was kind of the priority, and this worked really well. We specifically wanted to do integration tests against a live server. That went less well. So there's a price to be paid for that kind of convenience, right? So if you think about it, that live server had to be running, right? It was external to my laptop, so I had to have, authentication configured. Well, I also had to have it configured on the CI node, my laptop, all of the developers, right? But then there's all kinds of other things that could go wrong. So it was a shared server, so we did some rate limiting in the application. So that means if I was running my test and somebody else was running their test at the same time, they could potentially increase the rate limits or go over the rate limit. So our tests would start timing out. There's a whole bunch of problems like that that we had to pay the price for, right? So the big issue for us in this case was we didn't trust the server. So we're like, we're really going to run these tests against the live server because we didn't trust that system. And that way, the integration tests, when they ran, we always knew the server was good. Well, we weren't testing the server, we were testing the clients, right? So really, to fix this whole problem, we should have done something different, right? The server team, that compatibility issue, that could have been done some other way. And then we could have trusted that they were handling it, and then we could have worked in a more optimized fashion, mocking things out. I would have had a much easier time running the integration test locally. I probably could have wrote some heavy-ish weight unit tests for some of these things. So adding that server in the mix really added a lot of complexity.
So now we're going to have a look at how are you going to find flaky tests. The question here that is probably better is who are you going to call? Flake busters, of course. Yeah, so one way that is really great is just like I mentioned earlier that we have lots of issues with resource contention if you have parallel tests. You can use that to your advantage. You can just run the tests in parallel, and this can usually reveal many of the issues that you have with flaky tests. So for example, just like I mentioned, resource contention, but also if you have dependency on test data, because you might try to access test data in a certain state and then another test tries to do the same. And also you can detect if you have some dependency on the test execution order as well. And also, as a side benefit, the tests execute faster. who wouldn't want that, right? There are, by the way, in the ebook quite a lot of like mentions on how to do this with lots of different frameworks. So if, like how to do it with Playwright and other frameworks. So like Playwright and WebDriver.io are parallel by default. In Playwright, it's by default per file, but it's not by default like per test within a file. So it will just execute each file in parallel in Playwright, for example, but not like each test inside a file. In WebDriver.io, it also does it parallel by default. There it does it even like on a, within the file level. In Cypress, you can do this, but it's only in the cloud. You have to pay for that one. And you can also do this with JUnit, for example, and also Gradle. You can just configure it to run, for example, if you have multiple kinds of tests, that you can run them in parallel, and this will save you lots of time.
Yeah, so again, there's the QR code, there's slides, there's François' ebook. There's a previous recording of this talk if you want to send it to your colleagues. Anyone rerunning tests automatically to detect flakiness? All right, handful of folks. All right, good. So most of the common techniques around finding flaky tests is you keep running it. You just run it over again, hopefully automatically, right? You run it. If it passes, you're golden. If it fails, you rerun it again. So that's kind of the gist of how to find them. So for Maven folks, anybody use Maven in here? Mm-hmm. All right, we'll stand together. All right, yeah, so Gradle has a very similar concept. I'm a Maven guy, so I like to use Maven examples. So the first parameter here is the rerun failing test count. That's kind of your max bar. So I'm going to retry to run a test up to 3 times until I get a success. Once I get a success, I'm not going to keep rerunning it. So this is good to keep you moving, right? So this allows your team to have flaky tests, right? Which is a good thing and a bad thing. If your team is struggling with flaky tests now, maybe this will get you so you don't have to babysit your build for 8 hours, right? Which is good. But you're also kind of sweeping the problem under the rug if you're not doing something about it. And that problem is only going to get worse. So the second option is the default option with Maven, but essentially it's fail on flake count. If you set it to anything other than 0, it'll be that many number of flaky tests will fail. So if you set it to 1, no flaky tests are allowed, but the test runner will detect all of your flakiness. So you still have the benefit of detecting them, but also failing if you don't want to allow them in your system. So in general, I think this type of setting is a good practice. Again, if you have flaky tests that are bad enough where it's causing you problems, you want to be able to move past it, but you really, I stress strongly, don't abuse this system. So one gotcha I want to point out, and François sort of hinted on some of this earlier, is if you're retrying your tests, let's say 3 times, and each test has a 30-second timeout, well, now my 30-second timeout is now 90 seconds. And if I have 1,000 tests, that's a long day, right? So you really need to watch out if you have these long-running tests with extended timeouts, if you're also retrying them. All right, who has submitted a pull request that has caused a CI build to fail that had nothing to do with your change? Right, everybody, this is wild, right? And this is normal for us, right? But now that you can detect these things, we need to figure out what to do with them, right? So track them. This is the Spring Teams instance of Develocity. So you can go to that link at the bottom and see this. This screenshot is a little older, but at this time, this sample Jetty application test was failing pretty frequently. So we can see the yellow is the test reruns, the green is passes, and the red is actually failures. So I forget when I took this, probably 6 months ago. The Spring team does a really good job of fixing their flaky tests. This was fixed last I checked. They still have flaky tests, but they also do a good job of going back and fixing them. All right, so now that we know we can find them, we know we need to track them, let's talk about what we can do about them.
How do we deal with flaky tests? We just deal with it. Yeah, so one very effective measure is preventing them in the first place. Sounds easy, right? Of course, it isn't as easy, as you might know. But there are a few strategies that you can employ here. Like, for example, one that I really like is in pull or merge requests, just run new or change tests, or just logic that maybe has changed in your code. Maybe 3, 10, 50, or 1,000 times. Of course, this really depends on how many resources you have on your builds agent. But you can also obviously just run this overnight, for example, when you're not using your CI instance. So you can, for example, just have all of the new tests that were merged this day run overnight if you want. And this is really effective, surprisingly, at finding flaky tests, because obviously the tests are being executed tons of times. And actually, for example, Google even enforces in some of the projects, for example, that they have to pass 1,000 times in succession before they merge them, which is kind of crazy, but it really works well to expose flaky tests. So yeah, this is one very good way. And as I mentioned, you can also just run, if you want, if it's obviously very difficult setup, just having the new tests run overnight, you can just, for simplicity, just run all of the tests multiple times every night. I mean, usually you should have time for that, unless your tests are running for 1 hour maybe. But if your tests are somewhat manageable, then just try rerunning them like 10 times, 50 times, 1,000, depending on how big the tests are, how long they take to run. So yeah. And then also, one of them is telling your team.
So we've talked about a little bit about this already, but making sure you tell your team about your flaky tests and communicate to your team is really important, right? So everybody raised their hands, or almost everyone raised their hands about that, the CI question I asked, right? So if a teammate of yours told you, hey, this test is flaky, don't worry about it, that would have saved you a lot of time. Right? But instead what happens is maybe you retry the build, maybe it passes, maybe it fails. You spend a lot of time debugging into the issue. You get frustrated because it has nothing to do with your code base, your change, and you just waste, you spin your wheels, right? So you don't want to waste your team's time, right? Nobody wants to be that person who wastes somebody else's time. So tell your team, that way they're also not hitting the retry button in CI. And that's going to, exacerbate maybe if you have CI queuing issues, that problem just went through the roof. You're also spending more money, right? If anybody's building in the cloud and you have cloud compute costs, those dollars are getting burned because everyone's just hitting the retry button. So when a new flaky test is found, tell your team, I don't care how you do it, Slack channel, email thread, whatever, but tell them what's going to be done about it. You're taking it out of rotation, you're going to quarantine it, whatever it is, tell them.
All right, and then another one is if you have lots of flaky tests already. I remember in a software project I was in, we were having tons of flaky tests, and it was really to a degree where it was unmanageable. And I remember going to my product owner and telling him, we have so many flaky tests and they're causing us so much time that we waste. Can we maybe just set aside a few sprints and then just for a few sprints only fix flaky tests? You can probably imagine what the reaction was of the product owner, right?
He probably laughed.
Yeah, he laughed and he was like, great idea, let's do that, right? No, not at all. And they're like, yeah, no, that won't work, of course not. But then I had an idea. I was like, what if we just say, so each person that is in the team, like each developer, when a new sprint starts, they just fix a flaky test before they start a new issue. And the product owner said oh yeah, sure, why not? Yeah, let's do that. He didn't realize probably that he just agreed to us spending it kind of adds up, right? If you need, let's say, an hour or 3 maybe to fix a flaky test, and then you have, let's say, I don't know, 5 people in your team, it already agrees that you get 5 to 10 hours each 2 weeks if you have a sprint cycle of 2 weeks to spend on fixing flaky tests, which is really substantial. It might just sound like a little thing, right? A little ask, but this is kind of the cool thing about this technique, in my opinion. So just, when you have a new sprint, first you fix a flaky test, and then you pull a new issue, which is a really cool way of solving this.
So at Gradle, both the Develocity teams and the build tool teams both do the same thing. We call it a flaky test day. So usually what happens is after a release, if there were flaky tests that popped up that for whatever reason we couldn't fix immediately, the whole team gets together virtually, right? We're pretty remote at Gradle. And they go through the flaky tests, they sort them in order, the most flaky one, and then the team focuses on fixing them together, right? So this has 2 major benefits. The big one, obviously, it stabilizes our code base. That's the ultimate goal, is we want to make sure those things get out of the way. But the other thing is it teaches everybody that flaky tests are not acceptable, right? We don't want to keep them.
So one strategy you can use if you have a test that is flaky and you don't have time to fix it, maybe it's a test that was merged from somebody else in your team, and you have to urgently ship something, you cannot just fix it. One strategy that you can use is just to quarantine the tests. Quarantining means essentially you're kind of preventing the pipeline from failing, either by, for example, skipping a test, as you can see below for jest, and for JUnit, you can just simply disable them with @disabled. And then what I really recommend you to do is don't just put @disabled in front of it and leave it like that, because, at some point somebody will stumble across it and be like, why is this test disabled? Do we still need it? And it's really useful if you, for example, use a common keyword like quarantine : and then you can just search your code base for quarantine : and then you can find all of the tests that are flaky that you still have to fix. And then, maybe add a reason, mention why it's flaky if you can, or just say it's a flaky test. And maybe link to an issue if you have one. Then it's even better. Then you might make it easier to track it. And if you have an issue, you can just simply look for this issue number in the code, and you know which places to fix, for example. So yeah, this is just to make sure that your pipeline, is not failing anymore. Of course, what you could also try is, we have been talking about vibe coding a lot, right? But I don't hear people mention often that you could also use vibe coding in the other way, where you try to just use it to fix tests. Or like maybe, fix flaky tests. So maybe just try to ask the AI, oh, I have this test, it's flaky. Maybe try fixing it. And maybe, it can fix it instantly, and you're already done with this issue, and you don't even need to add a comment or something like that and quarantine it. Maybe that's like a great way that you can just try out. It might not always fix it, but still, if it just fixed it in, let's say, 1/10 of the time, you still save quite a lot of time, right? So yeah, give it a try. Regarding to quarantine, so it makes sense usually to quarantine the test like after the first failure. Don't just leave it in and merge it and think like, oh, maybe let's see if it fails some more. We don't know how flaky it is. So yeah, if the test cannot be fixed in a timely fashion, then there is an impact on the productivity of all of the developers. So you should really make sure to quarantine it. And then you should make sure you also fix the flaky test that you quarantine in a timely fashion, because otherwise, you know how it is. You probably forget about fixing it, and then at some point, find it like half a year later. Half an hour would be nice, of course, but yeah. Yeah, so maybe, of course, you can combine it with some other measures like we mentioned earlier, like the flaky test days or the fix one, flaky test sprint, just to make sure you can get rid of them timely. Also makes sense that you define, for example, a limit for of the items that you have in the quarantine. So let's say you can say we have like a maximum of 5 to 10 flaky tests that we are allowed to have in quarantine at the same time. And once we're above that, we have to essentially fix them. We're not allowed to have more of them. So this is also a great way of preventing them like piling up endlessly, essentially. And yeah, you can also, just like defining a limit for the amount, you can define a limit for the time. So you can say, okay, so it's quarantined, let's say for a month. And then if it wasn't, like fixed in a month, you have to fix it. Otherwise, you're not allowed to continue, for example, if you define this like as a team rule, for example.
All right, so in a perfect world, right, we would fix all of our flaky tests, right? So it hurts me a little to suggest, if a test is constantly flaking, it probably doesn't provide a lot of value, so you can also delete it, right? That's okay to delete tests that aren't providing value. If you have code in your code base that doesn't provide value, do you have any problem getting rid of it? Probably not, right? So delete it. So as François mentioned, if you leave that code commented, the test commented out or quarantined for a long time, someone's going to come back and they're going to uncomment it. It starts working again. And then the flaky test is back in the system, a couple days later. So, hopefully you took his advice, and there's a nice comment why this thing is out of rotation, what's going to be done about it. Here's an issue if you want to go track it. But if those code paths aren't valid anymore, or again, if it's flaking all the time, delete it, right? Or maybe instead of deleting it, you rewrite the test using a different technique. That's assuming that the problem is the test and not the code base. It's possible that the code base is the problem and the test is just fine. So you watch out there. But in general, right, if the test doesn't spark joy, delete it. All right. Who has had a test that only fails in CI and they cannot reproduce the failure locally? Yeah, more than I would have expected. Okay, so this is kind of the last resort type of things, and this really depends on the infrastructure and the CI system you use. But maybe you can SSH into that box, maybe attach a debugger to it. Again, this might not be possible in every scenario. The fallback for me is the print line debugging. Anyone big fan of print line debugging? Yeah.
Sometimes.
Yeah. I'm never a fan, but I always do it. But one alternative to this, if you're using, CI runners that were provisioned by your organization, maybe your IT team can provision you a runner that you can use to run it locally, or run the VM locally or something, where you can try to reproduce the issue.
So yeah, how do we fix the flaky tests? So here we're kind of defeating Murphy's Law, right? So one of them is make sure that your test data is consistent. So for example, make sure that you set up your test data with, if you're using JUnit 5, for example, where you have a before each block and then an after each block, where in the before each you create the test data, in the after each you delete the test data. In end-to-end tests, I really recommend you to not create the test data on the UI. What I really recommend you is to, for example, have a, like in a project where we had a microservice architecture, we just had a microservice whose job was just to set up the test data on all of the other microservices. This could also be an option, of course, that you just have to make an API call and it will set up the test data automatically for you. This way you can easily just tear it down again at the end and you are left spotless, and you can just create multiple sets of test data on demand and you don't have issues with parallel tests running. And then in Jest you can also do it with before each, and there are many similar things that you can do in all kinds of testing frameworks, whatever you use. And what you can also do is you can use test containers. So who of you uses test containers already? Okay, I see like a few hands. Maybe this is a great opportunity for the others to give it a try for sure. It's a really cool, I don't know if you can call it a library or like a tool, whatever, which allows you to essentially spin up a Docker container, for example, with your database, and initialize some test data within it, and then just use that specifically for that test. And you can define, depending on how, how much you want to be able to reuse that data or not, or how much you want to maybe parallelize your tests. You could, for example, even set it up to create a new test container for each test method that gets run. And then you can run them in parallel, no problem, and everything gets run in a separate little container. And then you can just throw it away at the end, and you're fine. So it's really a cool technique. Give it a try. Again, here you can click on the link, and then you can see how to do it.
All right. One of the other things that I love to point out is all tests should be isolated. So François mentioned kind of the reasons for this when you're running in parallel. Sergey also talked a little bit about this this morning, if anyone saw his talk. Tests need to be able to be run in parallel parallel so they don't share resources. But it's also a good practice, even if you don't care about running your test in parallel. So I can just click in my IDE. My IDE should be able to run a single test without any other dependencies, right? Single click of a button, I should get feedback as fast as possible. I shouldn't need to run a whole suite of tests for that one test method to work. I shouldn't have to go remember some incantation on the command line to run a single test. Remember, a single click is very fast. The overhead's low. If I want to debug that test, the debug button is right next to the run button. So I don't have to think about any of these things. It makes it a lot easier for me. So I had a test case a little while back where I was sure that I'd written the test correctly. Every once in a while, the test would fail. And I was very confused what was going on. But come to find out, the test run order mattered in my case. So I had some CRUD tests. So as long as the create test ran before the update test, the tests were fine, right? But every once in a while, the test ran in a different order. And of course, if the update test ran first, the test would fail. So the solution was really easy. I just made the test be able to be isolated. So the update test managed its own data that it needed. So the create test and the update test were no longer dependent on each other. All right, some other things I want to touch on. So if you're running tests in parallel, you got to watch out for things like system properties. So in the Java world, if you're setting system properties or basically anything that mutates the JVM sort of system-wide, you have to watch out for that. So if you're doing, I don't know, some sort of flag, if this system property is set, then do this behavior. Well, if you toggle that flag, then you might be toggling the behavior and some of your other tests may fail. So if you're running them in parallel, you have to watch out for that. You can still do this type of thing in tests, but you kind of need to isolate them off so you're not running them together. François also mentioned this, test files. So the Java folks, JUnit has a great tester annotation. But essentially, if you need to access your file system when running a test, use a temp directory, or you can create it. You know, in any framework or library will let you create a temporary file. It'll get deleted eventually anyway. So that ensures that your tests are independent. And the last one I like to point out is use a free ephemeral port. Who has hard-coded ports in their tests? Too many of us, right? So this is bad for a lot of reasons. If I have one of these builds that takes an hour long to run, right, I should be able to do something with my laptop while that's happening. And if all my tests are hard-coded to port 8080, and I'm commonly starting a service that runs on 8080, I'm gonna have a bad day, right? So just watch out for that.
All right, so then in end-to-end tests, which, you know, as we heard from Brian, have the highest chance of having some flaky tests in them. So one of them is you use deep links, for example, to navigate directly to the page to be tested. So, you know, probably some of you have this case as well, where you have a software project where you have a login page and then you always go through the login page. And this happened to me at some point where then suddenly the login was not working because, you know, it was down from maintenance or whatever, and we couldn't run any end-to-end tests. This was really annoying. So, you know, try to skip, for example, logins if you can, you know, like just on a testing environment, of course, don't do this on production. But yeah, you can try this, for example, or then just go on the website, on the page directly that you want to test. You know, of course, make sure that you also test, for example, going from a transition from one page to another. But then just don't write like one test where you have everything in one test, for example. Because then, of course, if just one little part in it fails, then the whole test will fail and you have to rerun the whole thing and it takes a lot longer. So yeah, if you use a deep link and you navigate directly to the page that you're testing, you're just trying this specific functionality that you want to test, then you're really good as well. Especially if something else is broken because, you know, maybe someone else has changed something and it wasn't, you know, fully finished yet. Then you can skip over that and just test your functionality. Also, when the tests fail, then you know, for example, oh, you know, the other pages leading up to it worked, but just, you know, this one page had this issue, so you know the pages before, they don't have an issue, so you don't need to look at that. And then you can also, just like I mentioned, start the test with the test user already logged in. And also what I really recommend you to do is make sure that you can run each test spec independently, so like each test file or whatever, just to make it easier to troubleshoot the issues. Don't expect, again, just like we heard in the dependency, that you need to run another file first and then another one. So yeah. So these are kind of strategies to contain the impact of the flaky test to its lowest attack surface possible. And another thing that you can do is, you know, just like we saw with the waiting for like let's say 1 second, 5 seconds, whatever. Instead of doing that, you know, wait for a condition to be fulfilled with a timeout. So let's say you wait for something to be displayed, and if that is displayed, then, you know, it's fine. Then we continue with the next assertion. And, you know, there you just define a timeout, and then you can be sure that it doesn't take, you know, it just takes the right amount of time and you don't waste time this way. And you should also use stable test IDs and selectors. You know, you're going to make your life a lot easier this way, because if you, for example, decide to switch from one library to another and it just changes slightly differently how the DOM is layouted, then you don't have to go ahead and change like, I don't know, 20, 30 selectors. I don't know, who has been in this hell before? Not that many? Okay. That's fine. I'm glad you didn't have to endure that. And also consider mocking external APIs. So for example, if you have multiple test environments that are available, it makes sense that, for example, in the earliest environments, you mock, for example, the endpoints. And in this way, the tests run much quicker. And of course, they're much more stable because if one of the APIs has some issues, then they won't fail because of that. Then maybe in the later stages, you could consider not mocking them. Of course, this depends on if you have throttling or rate limiting that is applied, especially if you're using like an external API where you have page requests. And obviously, this usually isn't an option. Usually you want to then just keep it mocked everywhere because you don't want to suddenly get the bill of like $1 million just for like that external API from the end-to-end tests, right? Yeah, so But of course, yeah, you need to decide from case by case.
All right. So one of the suggestions I always like to give when possible is if you're creating new tests or if you have to rewrite an old test, maybe move something from the right to the left, right? So maybe rewrite that end-to-end test as an integration test, or if possible, just as a unit test, right? This is going to speed up your build and increase the stability of your code base. So we mentioned this already, but often these issues are actually cultural, right? You start a new job and you're gung-ho, you're ready to make some sort of impact, and then you find out there's a bunch of flaky tests and somebody tells you to rerun them, and you just do that for a couple weeks and that becomes the norm, right? It's just the way it is, it's just the way it's always been. So it requires more energy to push against that, especially if you've been there for a long time. So, I would suggest all of you, most of you are very in the productivity space, right? So hold brown bag lunches, educate your team, make your flaky test visible. It's really hard to ignore if you have a dashboard. I know the teams I work with, we have every week, they go through the flaky test dashboard. If there's something they can fix during the sprint, they will. So once it's visible, you can do that. Track reruns, CI reruns. Who here tracks CI reruns? A couple of people. Awesome. So this is a big problem at a lot of orgs, especially if you have CI queuing issues. So that's one way to reduce that. But in general, make a business case for caring about it. Tell your boss that you're wasting developer time. If you're spending a lot of extra cloud compute, right? Those are dollars that you're burning. So maybe that's the business case you need to get your manager's ear. Thanks, everyone.
Right, thanks so much.